So this is our unit 3 where we're going to talk about proofs, and this is more just kind of looking at ways to make a statement and to kind of argue our point, not like argue as you think with people as much as with like being able to sensibly say, based on this, I know this, and like how we can do that. So this is something that you would go further into. Actually, if you were like to become a lawyer or that, you would use a lot of logic, inductive, deductive reasoning, those type of things and more. So we just briefly touch it. But when we look at our inductive reasoning, which is what this is, unit 3, goal 1, and I can use inductive reasoning to make a conjecture. So a conjecture just means I can make an educated guess based on, so inductive reasoning is a pattern. So based on a pattern, I can make a pretty good educated guess that this is the next one. The thing with inductive reasoning is that even though I can see a pattern, this happens, this happens, this happens every single time, and then I can make an inductive, a pretty good educated guess. It's not really a guess because I'm using past patterns to know that I can sensibly say this is for most likely going to happen based on what I've seen. Now, things can change. We all know that God is the true control of everything. So that things could change in our lives that way. But this is kind of reasoning that we use a lot, especially in the medical field. We, are looking at research and studies to make a good prediction of what is going to come next. So we're going to make conjectures based on inductive reasoning. So, and then to prove then that someone was wrong, if someone did make a conjecture, all you have to do is find one time where that thing happened, or what they said, when this happens, then I know this is going to happen. You just have to find one counterexample of the first thing happened, but your conjecture didn't happen. So very first thing is we're going to talk about inductive reasoning. Again, that is patterns. So when I'm looking at using inductive reasoning, I'm looking at this, what happens every time, and then looking at those patterns to make a conjecture of what the next thing is going to be. And a conjecture is kind of like an educated guess. It's based off of the pattern educated. Off of the pattern that I saw. And then again, like I said, a counterexample is something that the situation happened that I said, if when this situation happens, I'm seeing this always happen, and we don't actually see what we said would happen. So first of all, we use inductive reasoning to solve things like here. We're going to write a conjecture that describes the pattern 2, 4, 12, 48, 240, and then use your conjecture. So conjecture is kind of saying like, this is what I'm seeing as the pattern, or what I'm seeing as what's happening, and then I'm going to find the next item in the sequence. So I have 2, 4, 12, 48, 240. So I could look at first addition. So I kind of go through what we look at as our operations in math. So I could look at addition. This is adding 2. This is adding 8. This is adding 36. And this is adding 240. So I don't see really a lot with that. But if I go 12 divided by 2, I get 2. So this is times 2. This one is times 3, times 4, times 5. So based on that, we're multiplying by the next numerical sequence, the next number, the next consecutive number. So this one's going to be times 6. So that's my conjecture, that is going to be times 6. So if I multiply it times 6, probably should write times because x just means a variable, times 6, then I would get 1440. So this is what I'm conjecturing is happening, and this is what I'm saying is the next number in the sequence. So here we see these numbers, and I have to kind of figure out on this one, what does 3 represent, what does 9 represent? So if I'm looking at it, what they were representing, because it's not triangles, this is one triangle, this is 1, 2, 3, 4 triangles, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles, so I'm not seeing really, I mean, I could kind of think of what the pattern is on that, but let's look at what they're talking about. 3 is the number of sides, 1, 2, 3 sides there, or lines, 1, 2, 3, 4, 5, 6, 7, 8, 9 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So these 8 numbers are representing the number of lines. So based on those numbers, I could make a conjecture like this is 3, 9, 18. So I could look at, this is 3 times, that this is plus 6, plus 12. Could kind of try to figure out what my next conjecture is. You can kind of look at that we're going to look at adding another base of triangle. So this has 3, this has 4. So my next one would have 5 triangles here. Draw it out. So 1, 2, 3, 4, 5, too many. 1, 2, 3, 4, 5. That's 5. So this would have 7. So 1, 2, 3, 4, 5, 6, 7. Goodness gracious. And then they kind of go up from there. So I can kind of look at it, but if I'm looking just at those number of lines, can I decide what the next number of lines is going to be? So this is 9 divided by 3 is 3. 18 divided by 9 is 2. So I'm not really seeing anything with the numbers. So I look like, I kind of jumped ahead here. This is plus 9. I don't know what I'm doing here. I know what I'm doing, but this is plus 9, and this is plus 12 for the next one, which we can see from this drawing. That's going to be 30. So we see that we're going up by 3, so the next one's going to be plus 15. So if I'm looking at the numbers, my conjecture is that we're going to add 12, but also your drawing can be your next item in the sequence. So for the next item in sequence, but it's going to be plus 12, which would be 30 lines, and that should help us with those. So like I said, the drawing can be your next item in the sequence. So if I'm looking at here, this one's kind of not necessarily an addition or multiplication, but it's kind of hard to see. Kind of concentrate on these bottom ones. This is 2 squared, this is 3 squared to make 9. 4 squared gives me 16, 5 squared gives me 25. So I can make the conjecture is going to be 1 over 6 squared, which is 136. And then again, you can pause the videos, try this out, and then check your answer, and that will really help you if you try it first and then check your answer. All right, and we can also look at these with some of things we know. So make a conjecture, so I don't really have a pattern there, but I'm going to look at some, but like I said, I'm going to just try it a few times and see if I can come up with a pattern. So make a conjecture about the sum of an odd number and an even number. So let's just try some. Odd number 7, even number 10 equals 17. Odd number 5, even number 6. 11. So what am I looking at with all of my sums? What type of numbers are they? It looks like that, so here's some examples, but it looks like I'm going to get the sum of an odd and even number is always an odd number. So sometimes you have to look at, come up with the examples and then find the pattern. So here for points L, M, and N, LM equals, so we're going to use these with some geometric conjectures here. LM equals 20, MN equals 6, and LN equals 14. So I'm looking at these, and I'm going to draw a figure to illustrate it too, but it looks like since 6 and 14, how do they all relate? When I'm looking at 6 and 14, I can see that they add to be 6 plus 14 equals 20. So what do I know about L, M, and N? Well, I know L to M, so L to M is 20, and then L to N is 14, so M to N is 6, so that tells me that N, based off my drawing and what I see, N is between L and M. So sometimes we're going to have to really think about some things we've seen in the past. Product of two odd numbers, again, I would try some like 3 times 5, 7 times 9, and see what type of numbers. 3 times 1, am I getting 15, 63, 3. Notice these are all what type of numbers. The product is odd. So try this one. See what you think. Pause the videos, try it out, and then look and see if you have the same answer. All right. This is something that we can see where we're seeing it with predictions. We're seeing what do we notice about these sales. One is that they're always going up, but also when I'm looking at this 500 to 1500 to 4500, 500 times 3 equals 1500, 1500 times 3 equals 4500. So I could make a conjecture based off of this that in month 4 I'm going to have 4500 times 3. 14,550. And I can see that if I were to put that on a chart, that's one way I could easily see it. I can see that these are increasing pretty incredibly fast. So I can see that it's just going to continue to go on. Right, also same thing here. I can see they're kind of going up at a steady rate. So what's close to is the steady rate? Like, are they going up by, they're all about in the, so kind of look through them, see what if you can make some conjecture. Again, pause the video, I was going to go through it and check to see if you get the right answer. All right, so the last thing I can do is like look at a statement that's made, and this is something that we're kind of charged, we are charged in the Bible to do. When we're looking at statements that made, especially from data, we should really look at to see, is there anything that can disprove that statement? And if there is, then maybe that statement isn't true. So based on the table showing unemployment rates for the various counties in Texas, find a counterexample for the following statement. The unemployment rate is highest in cities with the most people. So we can kind of see that where we have 371,000 people, high unemployment rate. 713, like my larger cities seem to have big unemployment rates. So what is a counterexample? One counterexample is like this one. Not very many people, but he's up there in that same rate. And Maverick is a counterexample too, because it is a pretty one of the bigger ones, top 3, and it has or not the top, it's not a very big population, but it has a really high unemployment rate. So you're looking at these to find one of the cities where this statement doesn't hold true, and since it doesn't hold true in one, then it doesn't hold true in any. All right, so that is today's lesson.